Good afternoon. Today we will be going through the Q&A section.
Okay, so for question 1, for the various strain tests, how do you ensure that the pressure applied during point press, bend up and bend down are consistent across samples? So the answer for this is that we attempt different methods for bending and pressing tests.
So here what we have here is a visual illustration of how our strain sensor works. We bind it to a flexible ruler and some tape. Then we wind a rope around the ruler while supporting the sides. Afterward, we just pull to an equal displacement, hoping to achieve equal change in topological shape during each bend cycle.
For pressing, we attach a ballpoint pen that is capped to a string. We adjusted the length to make sure that when we drop it right, it will hit the strain sensor at the maximum length. Here the animation shows that it rebounds, but actually it will just remain there. But it will exert less pressure compared to the first impact when you drop it. We try to drop it at a constant height and impart no leaving velocity, but sometimes it is hard.
Question 2. So the question 2 is, what are the other MXene or GO-based aerogels studied in earlier work? Could you provide a benchmark of how your best aerogel, say 73, with optimal mechanical properties and conductivity, compares with similar MXene or GO-based aerogels? Well, so normally, other MXene or GO-based aerogel are used as terahertz radiation shielding. And in this video, we will compare 3 notable aerogel that have been reported and try to compare how the conductivity and mechanical property between our 73 aerogel and their one is. We can keep in view that our 73 mg aerogel has a conductance of 200 Siemens per meter.
So the first article comes from Lin. They use a slightly different method to assemble the aerogel. They use zinc foil in the process of assembling the 2D material. This method is quite interesting because there is a chemical process where zinc reacts with the acid to give zinc 2+ ions. Whereas for our method, if you recall, we drop magnesium 2+ solution.
So apparently, their conductivity is really high. And so here their MXene 4 is actually our 73 mg aerogel. And yeah, compared to theirs, their one is 5,000, whereas our one is 200. They are 25 times higher than us. And possible reason is because during the reaction of zinc 2+, there's some redox reaction. So the GO is reduced and actually some of the chemical is changed. So due to this reason that we have a higher conductivity.
On a more similar note, we have this article. Their procedure is almost similar to ours, but instead of using GO, they use SA molecules as their counterpart. They also use an elastomer, PDMS, to coat the aerogel to enhance the mechanical property.
For this, the comparison between the conductance is actually better because if you look at it carefully, for our 73 aerogel, which is at 70%, their one have conductance around 500, which is possibly because SA is called conductive molecules while GO isn't. So actually, our MG aerogel creator is agreed and fit with the literature values quite well. For the last article, we are looking at using MXene and GO together, but instead they did not produce an aerogel. I think they tried to dry it, but I want to highlight that we can compare the mechanical strength in this article. For this, you can see on the left that the MXene GO film is quite good. The stress become better when they incorporate GO into it. However, we have to note that this is a stretch test, meaning they stretch the aerogel, whereas for us, we do a compression test. For us, we also have a higher change, but unfortunately, we cannot find other similar tests that's compressing. So we can only compare and hope that our MG aerogel is as good as what they have said.
Okay, so when we compare all of our aerogels together, so we first compare conductivity. And we can see that for the first aerogel, for Maxine and Geo together with the Zinc 2+, it actually has the highest one with 5,000 units of conductivity, followed by Maxine with SA, which is about 500, and the last one is actually our aerogel that we produce, which is about 200.
Whereas for mechanical stability, we see that even though the Maxine plus Geo composition without elastomer is, we will say that it's better than our MG aerogel. However, this MG aerogel without elastomer, it incorporate like EcoFlex infiltrated into our aerogel, it becomes better. As you can see, it can bend. So a similar one would be the aerogel with elastomer such as PDMS. It's the same article as the Maxine plus SA. And I would say that their one is as good as ours. Yeah.
Okay, so we have come to the end. Thank you for listening to our presentation, and we hope you have learned more from our Q&A session.